Hey, welcome back. Over the past week, I've been continuing work on Project Blade, mostly building on top of the locomotion system from the last devlog and slowly shifting focus toward combat. I didn't try to tackle everything at once. The goal was just to get a basic combat foundation in place and see how it actually feels in-game. Once locomotion was in a decent spot, the next obvious step was figuring out what kind of combat experience I wanted this project to have. From the start, my goal here was to build a combat system that feels fast, responsive, and expressive, something that rewards momentum rather than patience. I'm personally a big fan of action games where combat flows continuously, where you're encouraged to stay aggressive, chain attacks together, and react on the fly. Games like Devil May Cry or God of War lean heavily into that style. That's very different from games like Dark Souls, where combat is slower, more methodical, and heavily focused on stamina management, precise timing, and waiting for the right opening. Those systems work incredibly well for that kind of experience, but it's not what I'm aiming for with this project. For Project Blade, I want combat to feel immediate. When you press a button, something happens. No lag, no hesitation, no guessing whether the input registered or not. So with that in mind, this devlog is about laying the groundwork for a combo-based combat system and seeing how it holds up in practice. With that overall goal in mind, the next step was actually starting to put some of these ideas into reality, beginning with the weapon itself. The first thing I worked on was setting up the weapon system. I started by creating a base weapon class that all weapons in the game can eventually inherit from. The idea here was to keep things flexible, so adding new weapon types later won't require rewriting everything. From there, I created a child class specifically for the spear, which is the main weapon used by the protagonist in this project. Structurally, I kept things pretty simple. I made the static mesh the root component of the weapon actor, since the weapon itself doesn't need any complex hierarchy at this stage. I also disabled collision on the weapon, because at this point, I didn't want it interacting physically with the world. For now, the weapon is purely visual. Actual hit detection and damage logic will be handled later through traces rather than physics collisions. Once the base weapon was set up, the next step was figuring out how the player would actually interact with it in-game. For that, I created a dedicated actor component to handle all weapon-related logic. Keeping this separate makes the system easier to reason about and keeps the character class from getting bloated. On the character side, I first set up a couple of sockets on the character mesh. One for when the weapon is equipped, and another for when it's unequipped. This makes it easy to visually control where the weapon lives at any given time. Inside the weapon component, I then implemented a spawn weapon function that runs on begin play. This handles spawning the weapon actor and attaching it to the unequipped socket by default. From there, I added a few small helper functions to equip and unequip the weapon based on player input, which simply reattaches the weapon between the appropriate sockets. At this stage, I'm not worrying about equip or unequip animations. The priority right now is making sure the prototype feels good before spending time making it look good. Before moving on, I also did a quick cleanup pass. I removed the old static mesh placeholder weapon that was directly attached to the character and switched fully to spawning the weapon as its own actor. I also added a couple of temporary debug input bindings to quickly equip and unequip the spear. The weapon now exists independently in the world and gets attached at runtime through the weapon component, which makes the setup much more flexible going forward. With the weapon system in place, the next step was letting the player actually attack. I started by creating a new input action for the light attack and added it to the character's default input mapping context. For now, I'm keeping things simple and using the left mouse button to trigger light attacks. Inside the character blueprint, I then hooked up the input action event to trigger the light attack logic. Once that was working, the obvious next step was to connect this input to actual attack animations, so pressing the button results in a visible action on screen. I went through my animation pack and started looking for some light attack animations that felt fast and impactful, something that would fit the aggressive combo-driven style I'm aiming for. I ended up picking 4 light attack animations that chain together really nicely and honestly just look pretty sick when played in sequence. Once I had those selected, I turned each one into an animation montage, which makes it much easier to control how and when they're played during combat. At this point, I had a few combo animations ready, but now I needed a way to pick the correct combo montage at runtime. Luckily, Unreal has a newer system called Dynamic Asset Selection, which is built around chooser tables. The idea here is that instead of manually selecting an animation in code or blueprints, you pass in some context and let the chooser decide which asset to return. For combos, this works really well. I can use things like the current combo index, gameplay tags, or weapon type as inputs, and the chooser gives me back the montage that best matches that situation. This keeps the combo system flexible and data-driven, which makes iterating on combat much faster without constantly touching core logic. With a plan in place for selecting combo animations dynamically, the next step was organizing the combat logic itself. For that, I created a dedicated combat component that's responsible for handling everything combat-related, things like attack state, combo progression, and triggering animations. Once that component was set up, I went back into the chooser table and added all of the light attack combo animations I picked earlier. I then bound the relevant variables from the combat component into the chooser, things like the current combo index and any state information the chooser needs to make a decision. This way, when an attack is triggered, the chooser can evaluate the current combat context and return the best matching animation to play, instead of relying on hard-coded logic. With all of that set up, I finally had enough pieces in place to test the combo system. And visually, things were working. The combo animations were playing in the correct order and chaining together the way I expected. But once I started actually playing it, a pretty big issue became obvious. The combo felt completely unresponsive. Even though the animations looked fine, the system wasn't reacting well to player input at all. If you pressed the attack button slightly too early or too late, the input would just get ignored, and the combo would break. So while it technically worked, it didn't feel good. And for a fast-paced combat system, that's a deal breaker. To solve this, I added an input buffering system. In fast-paced action games, input buffering is a technique that allows the game to remember player inputs for a short period of time, instead of requiring perfect timing. So if the player presses an attack slightly before the current animation finishes, the input doesn't get ignored. It gets stored and then executed as soon as the character is ready to accept the next action. This makes combat feel far more responsive and forgiving, without actually making it easier or less skill-based. A lot of action games rely heavily on this kind of system to make combos feel smooth and consistent, especially when animations are driving the timing. So the way I approached this was by creating another dedicated actor component just for input buffering. The goal was to keep it generic, not just buffer light attack, but buffer any input action I decide to support later. The logic is pretty straightforward. If the player presses an input during a buffer window, instead of dropping it, the system stores it as a buffered action. Then, when the buffer window closes, the component checks if anything is buffered, and if it is, it immediately executes the buffered action at the first valid moment. The important part here was defining when buffering is allowed. So I created an animation notify state that acts as the input buffer window. Basically, notify state begins, buffering is enabled. Notify state ends, buffering is disabled, and any buffered input gets processed. After that, I added this notify state to every attack montage that should support input buffering. Finally, I added the input buffer component to the character and integrated it directly with the light attack input. So all attack inputs flow through the buffer system instead of triggering immediately. After putting all of that together, this is how the final result looks. The attacks chain smoothly, Inputs register consistently, and the overall flow feels much closer to the fast-paced combat I was aiming for. With the basic combo system in place, the next thing I'll be focusing on is making combat actually interact with enemies. In the next devlog, I'll be working on attack tracing and hit reactions, figuring out how and when attacks connect and how enemies should respond when they're hit. And that's it for this update. This system is still very much a work in progress, but it's in a good enough place now to start building on top of it. Thanks a lot for watching and for all the support on the first devlog. It genuinely means a lot. If you enjoyed this one, feel free to stick around. I'll be continuing to document the process as I go. Thanks for watching, and I'll see you in the next update.